Hello guys, let's find the tangent and normal to this parabola right here, and we'll also be discussing the slope, which is just the tangent, and the equation of the tangent in slope form. So let's begin with the tangent. For the tangent, this is just the slope. The tangent of a curve is just the slope, which is y2 minus y1 by x2 minus x1, which is for the geometrical form, and for the calculus form, dy by dx. And you can choose either way to derive the tangent, but I'm going to choose the calculus one first, and I'll also show you the geometrical method later. So this is a parabola. Its equation is y square equals to 4ax, meaning that its vertex, let's say right over here, lies at the origin, and let's just differentiate right away. So with respect to x, of course, this will be 2y dy by dx is equals to 4a, and dy by dx, which is our m, will be equals to 2a by y. Now let's say the tangent touches a point x1 comma y1. That means the slope at this exact point right here will be 2a by y1. And simply put this slope in the equation of a straight line, because tangent is a straight line. Y minus y1 is equals to m x minus x1. This will be y minus y1 is equals to 2a by y1 x minus x1, and here it will be y1 minus y1 square is equals to 2ax minus 2ax1. Now from here it looks like we can simplify, but you'll notice an odd one right here, y1 whole square. That is similar to y square, and in fact you're going on the right path, because here we can also substitute that y1 square is equals to 4ax1, because this point simply lies on the parabola, hence must satisfy the equation of the parabola. So substitute that value right here, you'll get minus 4ax1 is equals to 2ax minus 2ax1. As you see, we have a common term right here, and when this goes to the right hand side, this becomes plus 4ax1. So we'll have y1 is equals to 2ax minus 2 plus 4, that is plus 2ax1. And you can leave it here, but let's make it a bit nicer and take the 2a common. It'll be x plus x1. Now this is for the equation of tangent for the parabola y square equals to 4ax. Now if you want to find the tangent for the parabola x square equals to 4ay, which is just like this, then all you have to do is interchange x with y and x1 with y1. So for this you'll get x1 is equals to 2a y plus y1, and if you want to know how, you can do the same procedure and you eventually end up with this. Now let's move on to the geometrical method, which is a bit tougher but also very interesting at the same time. Let's go. Now for the geometrical method, instead of taking the tangent first, we have to take a secant line. Oops, sorry. Like this. So basically a line touching 2 points on this parabola. Let's say this is P x1 comma y1, and this is Q x2 comma y2. And we are doing this because the point is that what we'll do is we'll approximate P to be very very close to Q, which is just the principles of calculus. As this point P tends to Q, that means when it gets so close to Q that these 2 points will eventually just become 1 point, and that line will just be the tangent. But first we need to find the equations for these points individually. So for this parabola, generally it's y square equals to 4ax, and for a point x2 comma y2, it'll just be y2 square. 4ay is equals to 4ax2, and for y1 it will be y1 square is equals to 4ax1. And here, as you can see in the slope, we are trying to find y2 minus y1. So simply from these two equations, you can just simply minus them. So it will be y2 wholes, or y2 square minus y1 square is equals to 4a x2 minus 4a x1. And here this is just y2 minus y1, y2 plus y1, and this is 4a x2 minus x1. And here simply we can just divide both sides by x2 minus x1 and we'll get our slope. So on the left hand side we'll have y2 minus y1 x2 minus x1 whole into y2 plus y1, but in the same step I'm just going to put that down there. Now we have that this is just our slope is equals to 4a by y2 plus y1. Now let's use the logic as I said before. As p tends to q, but to make it easier, let's take that q approaches p. So when q approaches p, that means this y2 will be very close to y1 and they'll always be equal to each other. And when q approaches p, this secant line will become the tangent. So right here we have the slope is equals to 4a, y2 is equals to y1. So that means we'll have y1 plus y1, that is 2y1. And just cancel the 2's, so we'll have 2a y1. And as you can see, we got the slope as we did by doing derivatives. And you can do the same procedure, which is take the equation of the line and then just put the slope in and simplify. And quickly it's just this right here. And similarly, if you have the parabola x squared equals to 4ay, it's the same as before. X1 is equals to 2a y plus y1. Now let's go on to the normal to the parabola. For the normal, it's just a perpendicular line to the tangent. So what that means is its slope will be the perpendicular slope to that of the tangent. So we know the slope of the tangent, or the slope that is the tangent, is 2a by y1. And for the normal, let's call it m prime. This is 1 minus 1 by m, which is minus 1 by 2a by y1, which is minus y1 by 2a. And here simply put that into the equation of straight line like before, and you have y minus y1 is equals to m prime x minus x1. Substitute the value for m prime, you'll get minus y1 by 2a x minus x1. So 2ay minus 2ay1 is equals to minus xy1 plus x1y1. Now from here you can simplify a bit further, but you don't really get as nice of an equation of the tangent. So that's why you can leave it here if you want, and from here you can proceed, maybe put the plus in front like that as you wish, but I'm going to leave it right here. And let's move on to the tangent in slope form. So the tangent in slope forms mean that we want to express the equation of tangent as y is equals to some form of m and in some form of x as well. So function of m and x. And this is different from m is equals to 2a by y1, because instead of substituting the value of m, we have to just use m in the equation. So let's see. We can use the general formula for a straight line, which is y equals to mx plus c. And we know the equation of the parabola. This is y squared equals to 4ax. And simply substitute the value of y in here, and you'll get mx plus c whole square is equals to 4ax. So m square x square plus 2mxc plus c square is equals to 4ax. So we'll have m square x square plus 2mxc minus 4ax plus c square is equals to 0. We'll have m square x square plus, here we want to isolate the x such that we have a kind of a quadratic equation. So you'll have 2mc minus 4ax plus c square is equal to 0. Now we see we have the quadratic equation right here, but you don't want to use the quadratic formula or the quadratic equation to solve for x, because you have to remember one thing. We're trying to find the tangent to the parabola. What that means is just a single value of x. There cannot exist two values and only one value of x. So that can only happen is when you have b square minus 4ac. So the quadratic equation or the general formula is x squared plus bx plus c is equal to 0. So you can have only one equation or one value of x when when b square is equals to 4ac. And in our case, our a is m square, our b is 2mc minus 4a, and our c, which is the constant part, is c square in our case. And we just have to substitute these values in over here, and let's try to simplify it. So you'll have 2mc minus 4a whole square is equals to 4 into a is our m square and c is our c square. So open up the brackets, you'll get 4m square c square minus 2 into a into b, which is 16 mca plus 16a square is equals to 4m square c square. So we can nicely cancel these two over here, and we'll have 16a square is equals to 16amc. And you can cancel the 16s right here, and you have to check, can you cancel a and a? Because you can only do that if a isn't equals to 0. But we know from the equation of the tangent y square equals to 4ax, a cannot be equals to 0 because it is the focal length, and in a parabola there must be a definite focal length. So we can cancel these, and you'll have a equals to mc. Now you cannot kind of leave it at that, because as you can see in the equation of tangent we have y equals to mx plus c. So what's bothering us is really this c over here, because we already have one m over there and we just want the whole thing to be in terms of slope. So from here we can just see c is equals to a by m and substitute that in. Therefore you get y is equals to mx plus a by m. So we can also see this as a condition for tangent. So for a line to be tangent to a parabola, the c, which is the constant value for the equation of tangent, this must be equals to a by m. And this is the tangent in slope form, and we can also find the normal in slope form right here. Now for the normal in slope form, what we'll have to do is we'll have to see the equation of the normal, which is y minus y1 is equals to minus y1 by 2a x minus x1. So that means the slope of the normal is this, which is m is equals to minus y1 by 2a, and you'll get the value of y1, which is minus 2am, and similarly you can substitute for x1. So we'll have y1 square is equals to 4ax1, and that means x1 is equals to y1 square by 4a, and we know y1 is minus 2am. When you square that, you'll get 4a square m square by 4a, and nicely you'll get am square. And you'll have to substitute the value of y1 and x1 in this equation right here. So you'll have y minus y1, which is minus 2am, minus minus becomes plus, is equals to this right here is our m, x minus am square, and y is equals to first mx minus 2am minus am cube. Now simply here we get the value or the equation of the normal in slope form. Now you may be asking, why we didn't do it like before, taking y equals to mx plus c, y square equals to 4ax, and continuing forward. Well, because you have to remember one key fact. Tangent just means it touches one point on a parabola. That means it satisfies for just one value of x. So a tangent could be right here. That means at this specific point that x will have just one x value. But a normal is such a point where it's perpendicular to the tangent. So that could mean that it passes through 2 points on the normal. At that point you can't just simply solve as b square equals to 4ac like we did before, because this is not true anymore for normal, and thus we have to do this approach right over here. So this is it for equation of tangent and normal and to the parabola. So if you guys done something new, please like and subscribe. Thank you.